Hello again and welcome back to another video where today we're continuing on with our Unreal and Wise adding game sound series. The goal for today is we're taking our Footsteps system one step further. We're going to make it dynamic. What we want to do is trigger different footstep sounds depending on what material we walk on. So when we walk on these tiles we can see in front of us we hear tile footsteps, but there's also grass that we want to hear grass footsteps on. And we're going to do wood as well for those wooden crates you can see as well. As always, before we start, if you'd be interested in following along, hearing updates and news and little changes I'm making to this channel and any new products I release like online courses, then you can follow along with my newsletter where I'm giving away free lessons, two free lessons actually, one from my Fmod and Unity course and another from my soon to be released Unity course. So if you're interested, I'll have links in the description below. Okay, so here we are in Wise. This is where we left off last time, and the first thing we're going to do is jump into the game syncs tab, and we're going to talk about the new feature I mentioned, or new to us anyway, and that's switches. Now in Wise you have this feature called switches, and the idea is that whenever an event is triggered using a switch, you can change which container of audio is triggered. So in this case, whenever a player walks on a grass surface, using a switch, we want to change from one of those random containers we created in the last episode that play tiles and switch to a new one we'll create that contains grass footsteps. And then whenever, let's say they move back to tile, we'll switch back to the tile containers. On top of this, we're also going to redesign how we're sort of triggering our footsteps. At the moment, remember we've got two events. We've got a running and a walking event. What I'm going to do is I'm going to compress this all into one event now. The idea is that we'll have an event that just says footsteps, right? It's just called footsteps and it controls everything to do with the player's footsteps. Then the first thing we'll do is using a switch, we'll determine what material type we want to hear. So is it going to be grass, wood, or tile? Then once that's decided, we're going to then determine at what speed the player's running at. Is the walking animation being used or is the running animation being used? So because Unreal is going to send us two different pieces of information, which we're going to use to then determine what sounds we play, we're going to need two switches. So what we're going to do is, let's start with the first one. Let's click on the default work unit and we're going to click this button here called create new switch group. Now this first one I'm going to call material, and this is going to determine which material type we're going to hear, grass, wood or tile. Once we've created our switch group, we want to populate it with switches or options that we have to choose from. So let's now click this square button that says create new switch. The first one we're going to name these after the materials. So we'll start with tile, as that's what we've been using so far. The next one will be grass, and the third for now will be wood. There we go. So that's the first switch group. Let's create another. This one is going to represent whether we're walking or running. So let's call it walking, running. Then I'm going to create two more switches. The first one's going to be walking, and the second is, of course, going to be running. And there we go, we have our switch groups. So let's save those. Now let's jump over into the audio tab and look at how we're going to use them. So at the moment, we've got two random containers, one called running, one called walking. Now these are populated with tile sounds. If I quickly play one to you, that's supposed to be the sound of someone walking on a tile, right? Now, we're going to need some more of these, but with, wood sounds and grass sounds instead. Before we create those, though, what I'm going to do is create a new container called a switch container. Now, using a switch container, you can basically trigger one of two, one of three, or, as many as you want, really, different containers using that switch group, or one of the switch groups we created earlier. So let me click on that, and this first one is going to be called Footsteps, and this is going to be like the main container now for our Footsteps event. Then inside that I'm going to create another one called Tile. Then I'm going to take my running and my walking random containers, I'm going to hold shift to highlight them both, and I'm going to drag them into Tile, so they're now children of that switch container. So again, the way this is going to work, the Footsteps switch container is going to trigger, then using our switch group of this one here, material, we're going to determine what type of material we're on. So let's say it's tile. The tile switch container will then trigger. Then we're going to decide whether or not we're walking or running. And then from there, we'll determine which one of these random containers we're going to play. How do we set that up? Well, let's click on our first switch container, Footsteps, and we want to go in the general settings. We want to go to this section here called switch. So let's click group, and we're going to select which switch group we're after. So the first one is material. Then as a bonus, not a bonus, as an option, you can choose which default switch you like to set. So this is basically on the off chance that a switch couldn't be found or there's an error. Wwise has something to fall back on, so at least you play something as opposed to just nothing in case it for some reason can't find a switch to choose from. I'm going to click tile. You can choose whichever you want, really. I suppose my advice would be whatever you think the player would hear the most, right? So let's say you've got a game that's filled with loads of grass areas and only a few tile areas. You'll probably want the default to be grass because it's more likely the player's going to be walking on grass if an error were to occur, okay? But I'm just going to use tile. Okay, so once you've attached your group, you want to use the contents editor here to assign the containers you have within your switch container to those switches. Now, I've only got one at the moment, so before I do that, I'm going to add a few more. I'm going to select my Footsteps container so that I create a new container inside it, and I'm going to create 2 more switch containers. These are going to represent those other materials. So let's start with grass, click on it again, and let's also add wood. Okay, then if I click back on Footsteps, now we've got a few more options in the contents editor. So let's assign these containers to our switches. So obviously grass is going to grass, so just click and drag it onto one of these in the assigned object section. Wood is going to go to wood, and obviously tile is the default. We're going to drag tile onto tile like that. There we go. And let's just make this a bit bigger so we can see that now they're all assigned. So now in our game, when this Footsteps container is played and told one of these 3 switches, let's say grass, it's then going to trigger the grass switch container to play. Now, like I said earlier, we're not done there because we also need to tell it whether or not we're running or walking. So what I'm going to do is I'm going to duplicate these random containers, and I'm going to add them to both the wood and the grass switch container, and then I'm just going to replace the audio. So again, I'm going to highlight them both. I'm going to hold Control and C or Control V if you're on a Mac. Then let's say click on wood and press Control V. And again, let's click on grass and Control V. Okay, cool. Okay, so I'm going to start with the containers I now have in grass. So let's open these up. These will contain tile audio. So what I'm going to do is highlight them all, delete, highlight them all, delete. Okay, then I'm going to click on running. I'm going to right click and let's import some new audio. Let's go import audio files, add files, and then I'm just going to search for the audio files I have. Again, if you're following along with this series and you'd like some Footstep files to use for this, there'll be a link in the description to my website where you can download some Footstep sounds. Right, so let's go. So this is running I'm doing, so let's find my grass running sounds, highlight them all, click open, and import. There we go. So now the running container within the grass switch container actually has some grass sounds. So if I play that for you now, cool, we get some grass sounds. Now, I'm going to quickly blast through the walking random container as well as the running and walking random containers under tile and re-import the correct audio for them. So I'll be back in a sec. And there we go, cool. So I've got 6 random containers in total. My first one contains grass sounds, or the first 2. The second 2 contain tile, and the third 2 contain wood. And then if I minimize these quickly, we can see that they are all children of those 3 switch containers I created: grass, tile, and wood. Now, the reason why I wanted to duplicate those random containers is because, remember, we set up some random audio modulation in the last couple of episodes, as well as we used some parameters, didn't we? So these parameters will still work for the running and walking. Well, it was only running we did it for. But for these running random containers, that parameter we created will still work. It will just now play different audio files. Okay, we're nearly done. So let's go back to general settings. Let's start with the Footsteps switch container. So we've set up the material switch group for the Footsteps random container, and sorry, not random, the switch container. So using material and one of the switches will determine which one of these switch groups will be played. But like I said, within those, we also want to determine which random container is going to be played. So let's start with grass. We also want to assign a group to that. So if I click grass, group, switch groups, and we're going to use the walking running switch group. Again, let's give it a default switch. So we're going to use running because the player's mostly running. And then let's assign them. So the running random container within the grass switch container is going to running, and the walking is going to walking. I feel like I'm saying the word container so many times. Hopefully this isn't confusing. We haven't done tile, so let's do that. Switch groups, walking, running, and then let's assign those. And last but not least, let's click on wood and give that the correct switch group as well. And there we go. Cool, we're all done. So my Footsteps switch container has a switch group, and each container within it is assigned to one of the switches within that group. And then if I click on, say, grass, that also has a switch group assigned with different switches, and the containers within that are also assigned to switches. And then obviously random containers are random containers. Now I know that was a lot. We kind of did 2 switch groups at once. Hopefully that hasn't confused you. But yeah, that's pretty much everything done on the container side of things. So let's minimize that. So we just got Footsteps, and let's hit Control S to save. Now what's nice is you can test this. If I click on Footsteps and press play, we're here in grass, but if I go to the switches, or click on the switches at the bottom here, let's drag this over so you can hopefully see without my camera blocking. We can choose which material we want to hear. So let's say wood. There we go, we hear wood footsteps, but we can also determine if we're walking or running. There we go, cool. So you can use this to test to make sure your switches are working. Cool, containers are done. Now the next thing to do is to move over to events. So, like I said earlier, in the last couple of lessons, we were using 2 different events. We've got running and walking. Well, what we're gonna do is sack them off. We're gonna get a new event, and like I said, that's just gonna be called Footsteps, and we're gonna use that instead. And what that's gonna do is play that Footsteps switch container. So let's create a new event. Let's create event, and we're gonna call it Footsteps. There we go. Then what we want to do is, using our audio tab, we want to assign the Footsteps switch container to the event. So drag it into the event property editor, and we can just leave it like that. We want the play type to be play. We want it to play as this event is called. And then let's hit Control S and save that. Last thing to do is to click F7. We're going to go into the sound banks layout. Now let's click on our main sound bank. Now we've got 2 events missing because we deleted them, right? So let's get rid of those, click on those and delete them. And let's assign our new event to the main sound bank like that. There we go. Let's hit Control S to save. And one final time, let's click Generate All to generate all our sound banks, despite the fact there's only one. Cool. And with that, that's everything done on the Wwise side. So one more time, just because I'm getting paranoid, I'm saving. And yeah, let's jump over to Unreal. Okay, so there is a lot to do on the Unreal side, so we better get busy. The first thing we want to do is create a new event for the Footstep event we created. So let's go into our Wwise folder. Let's go events. Now these running and walking events that we looked at last time can go now. We don't need those, so I'm going to click on those and delete them. And let's just, so obviously now it's panicking because it's saying, oh, those are being used in a blueprint. Obviously we're using those in our animation blueprints. So it's saying, are you sure you want to delete them? But it's fine because we're going to create a new one and we're going to replace those with that new one. Okay, once you've deleted those, let's right click, let's go to Audio Kinetic event, and we're going to call this Footsteps. Now again, like I said in the first episode of this series, it's vitally important that the name of this event matches exactly with the name of your event in Wwise. So spelled correctly, same capitalization, and all of that good stuff. Then what I'm going to do is not right click it, double click. Let's assign it to a required bank. So our main bank, let's hit save. Let's close that. Then let's go back into our Wwise folder, click banks. Let's then double click on the main bank. Let's save that as well. Then I'm going to right click on it and I'm going to click generate selected bank. And just main, all available platforms generate. There we go, that's done. Let's go back into our Wwise folder, back to events. Let's right click it and let's see if it plays. If I hit play, there we go, we hear a footstep. Obviously, we just heard a random footstep there because we haven't sorted those switches out. Or rather, you can't. I don't think you can control them from this perspective. This is just for testing purposes. So cool, we heard it. Everything's set up in Wwise. Right, now, moving on. So the next thing we want to do is we want to create a couple of things. We want to create things called surface types, and we also want to create physical materials. Now, what are those 2 things I just mentioned? Well, if I zoom out a bit, obviously, we want the player to, or the the sounds that the player's making as they're walking, to change no matter where they are in this world. So whatever they can walk on, we want to be able to detect and check for a material. So the plan is we're going to use surface types basically, and we're going to assign a surface type to everything, or most of everything, that the player can walk on, okay? Those surface types are obviously going to be the tile, wood, and grass types that we were talking about earlier. The way we do that is by creating a physical material, and we're going to create one for each of those types. And what they are is basically like an actor that you can attach to textures and objects in Unreal. I'm going to show you two ways you can attach those two objects in Unreal, and give you some perspective on what cases or scenarios you might use either one of those methods. But yeah, that's the plan. Create some surface types, assign those types to physical materials, and then attach those materials to, say, this grass island, the tiles in this little hut, those wooden crates, etc. Okay, so we're going to go to Edit in the top left corner. Let's go Project Settings. And let's find we want to find a tab called Physics. I think it's under Engine. There we go, Physics. Let's click on that. Then let's scroll down to the bottom and we'll find a section here called Physical Surface. I'm actually going to maximize this so we can see what we're doing. So here's where we can create our surface types. So let's just create 3, one for each of those different audio file groups we've got. So let's say one called Tile, one called Grass, and one called wood. There we go. And let's hit Control S again to save those, and then close that. We've got our surface types now. Now we've got those, we want to create those physical materials I mentioned. So what I'm going to do is going to go back to my content folder, and for now I'm just going to create them here, and later on I'll find a place to keep them nice and organized. So let's right click an empty space in the contents folder. Let's go Physics, and let's select physical, there it is, this one here, physical material. So let's click on that. Then let's just click on physical material and let's click select. Okay, now I'm going to call this, again, this is going to represent one of those surface types. So I'm going to call mine material underscore tile, I guess. There we go. Then let's just press Control W to duplicate it. Let's also do it again. So there we go, we've got 3 now. Let's also change the name of these other 2. So we don't want tile, we want one called wood. And let's change that to grass. Cool, so we want to give each of these a surface type that we created earlier. So let's double click on grass. Let's find where it says surface type, which is right at the bottom here, physical properties. And instead of leaving it as default, let's select grass, and I'm going to save that like that. Close that window and then do the same for these 2. Okay, so now we have our physics materials, all of which have a surface type assigned to it. It's now time to look at how we can assign those physics materials to the various surfaces in our game. Now, earlier I said there was 2 ways you could do this. There's actually 3 I've discovered, so we're going to look through all 3 of those. The first way is using textures. So as you can see, every actor, every object in most games has what's called a texture, and a texture is basically the pretty pattern that is displayed on top of the object. So these tiles and these blue tiles are a texture, these brown ones are a texture, the grass is a texture. So what I'm going to do is I'm going to click on one of these islands with grass on, and what I'm going to do is assign this grass texture with that grass physical material. So what I'm going to do is come down to the details tab on the right here, and under materials I want to select the material the texture that's being used on this object. So I'm going to double click. I'm actually going to do it to both of these just to play it safe. What we're going to do is double click on one, and here we open up a new window which displays the texture that we're using on that object. Now we're not interested too much in how it looks in this view. All we want to do is scroll down to details, scroll down the details tab, and under general, where it says physical material, just click on the none box, the none drop down, and select the physical material you created earlier. So let's click grass. Then in the top left corner, you just hit save. There you go, and then close that. Let's do it again for this second one here called underscore grass underscore master. Let's double click, zoom out a bit. Let's scroll down to details, and again, let's assign the grass physical material. Cool. Now let's close that. So now every object using this texture will now have that physical material assigned to it. So if I click on another island, say this one, because they're using the same texture, if I double click on the texture again, When the player walks on, the same physical material will still be red. So that's method number 1 of assigning physical materials. The second way is by using the meshes that make up the object. So a mesh is basically a shape. And that's a really basic way of putting it, but that's all we need to know for this. It's the shape that makes the object. So in the case of, or the actor rather, so in the case of these wooden crates, the actual 3D cube that they've used, you know, with some, you know, details around the edges, because, you know, obviously want to make it look like there's wooden panels on it, that's the mesh. So we can assign a physical material to that. So again, on the right, in the details window with the object selected, instead of materials and clicking on the texture, let's double click on the mesh being used. Oh, let's zoom out a bit. And again, if we scroll down the details window, this time we want to go under collision where it says simple collision physics material. And this time we're going to select wood and then save. Close that. So now every object using this mesh will now have that physical material, the wood physical material, assigned to it. And the final method is using neither textures or mesh and just individually assigning objects, different objects in your game with a material manually. Now, the reason why we're going to do that is because of these tiles here. Now, you'd think we could just simply use the texture, right? So whenever an object has this bluish tile texture on it, we could assign the tile material to it. Problem is, if I click on it, this texture is being used for two things. It's actually being shared between anything that has wood on, i.e. these wooden boxes. If I zoom out as well and come down here, there's also these wooden panels that the player can walk on that also use the same texture. So if you see, it says m_kit floor. In fact, it's using the same mesh as well, sm_kit floor. So it's sharing the same mesh and the same texture with, oh god, with these tiles here. So really, textures and meshes aren't an option here, so we need to assign the material manually. For those ones outside, it'll be wood, but for inside, it'll be tile. In fact, if I click on this same middle object here, I keep calling them objects, I should say actors really, too much unity. If I click on the middle one, go to the transform section under rotation, I'm just going to rotate it basically, I'm going to lift it up, and you'll see that underneath it is wood. So the way the designers of this game have sort of made this object, they've made it sort of two parts, if that makes sense. They can use it as either tile, but if they want to use it as a wood surface, they just flip it upside down and bang, there you go, they can use it as wood. Quite clever really, but like I say, confuses or complicates things for us. So that's why we're going to have to individually assign materials to them. Going back to the mesh we talked about, I think for the most part, the developers are using this side of the mesh rather than its wood underside, right? So I think the way I'm going to do this is using this mesh, I'm going to assign the tile material type 2. So again, scroll down to collision and click tile. Then let's click save and close that. However, on the off chances that say we have it the other way around, so in this case it's the same mesh but flipped upside down, I'm going to manually assign the physical material. Now the way you do that is you click on it and scroll down the details window all the way down to collision, and you want to come here where it says physics material override. So here, once again, let's click the material 1, which in this case is wood. Okay, so now this tile specifically will be wood, however, all the indoor ones will, all these ones here will be tile, because again, that mesh we've assigned with the tile material, so all these ones using the sm_kit floor mesh will be recognized as tiles. But this one out here will be wood, despite the fact it's using the same mesh. And so what we'll have to do, what I'll have to do off screen, is go around this entire game and find any of those tiles that are upside down and using the wood side, and manually add the right material, the wood material. Okay, great. So we have our sounds in Wwise, we have our new surface types and physical materials with those surface types assigned to, well, not all, but most of the actors and objects in Unreal. Now it's time to look at the blueprints that we've been looking at in the last lesson, our animation blueprints, which we're going to use to detect what surface we're on and then play the recording audio file, right? So, as always, in our contents folder, let's click on Teachers Marketplace, Assets, Character again, Animations, and then we want to open up our run_animation animation blueprint, and then of course click on blueprint in the top right corner. Okay, so where we last left off, we have our two notifiers, one for the run animation and one for the walking animation. Now, like I said, we're redesigning how our footsteps work. So instead of using two post-event nodes, we're going to be using one. Now, I think the best thing for us to do really is start again. So what I'm going to do is I will be deleting all of this stuff, but for now I'm just going to leave it where it is and we'll pick things apart from it. So for simplicity's sake, I'm going to borrow the play run step node that obviously triggers whenever a footstep from the running animation is triggered. So what we'll do is right click on the pin that's connecting it to, in fact, hold on, let me zoom in so we can see what we're doing. What I'm going to do is disconnect it basically. So I'm going to right click the pin, I'm going to click break all pins so we lose that link to the set RTPC value node. And then what I'm going to do is just drag it all the way up here and I'm going to start again. Okay, so as soon as our little character over here takes a step, what do we want to happen? Well, like I was explaining earlier when we were back in Wwise, whenever our player takes a step, the first thing we want to check for is what material they're on, and thus which one of these we're going to trigger. Then once we've got that information, we'll look at which one out of the two, running or walking, we want to trigger. So let's jump back into our blueprint. The first thing we're going to do is check the material. Now the way we're going to do this is using what's called a line trace. Now if you ever watched any of my Unity stuff, you might be familiar with ray casting. Well, this is pretty much the same thing. What we're going to do is in Unreal we're going to draw a line from the center of our player going straight down. Now when that line hits something, we can check that object or actor for information. We can check its name, its location, or its physics material. Ha ha ha! And thus we can use that to trigger our footsteps once we know which physics material is attached to the actor we're on. Okay, so off of our first node, let's drag a new little line, and what we're going to do is type in line trace, and we want to use this one, line trace by channel. Okay, so this is the node that triggers that line to be drawn from the center of the player in any direction, by the way. It doesn't have to be down, but in our scenario we want it to go down. So the first piece of information we need to give it for this to work is where in the world is this line going to start. We need to tell it to start at the location of wherever our player is. Now before we do that, let me quickly jump back into our sort of main scene in Unreal and just very, very briefly talk about vectors. Now this is obviously a 3D world, right? It's on a 3D axis. So we've got the Y, the X, and the Z axis, okay? And every object, I keep doing that, every actor in this 3D world has a location defined by coordinates of those three axes. So this little hut, for example, could be, I don't know, position 23, 103, -3. Do you know what I mean? And if we click on it and look at the transform under location, we can see actually its coordinates. So the X on the x-axis is -2800, Y -2000, and Z 400. Okay. Now what we need to do using our blueprints is find out, or check rather, whenever a footstep is taken, where in the world our player is, what its coordinates are, and then give that to the line trace by channel node. Okay. Now the way we do that is nice and easy. We're first going to use a node that we've looked at before, get owning actor. This allows us to basically target the animation, basically, or the character using this animation. Once we've done that, let's drag a little pin or a little line off of the return value. We want to use another node. This one, if I can remember what it's called, get actor location. There we go, that's what we want, get actor location. Okay, so notice how the first line we've got here is blue. This is just like a reference, basically. It's an object reference. It's sort of referencing this object as a whole, right? This next one, however, is like a yellowy orange. Let's zoom in. It's like a yellow, I guess. And we want to drag that into the start pin here. Okay, now I think it was the last lesson. If it wasn't, it was episode 1, where we talked about data types, right? And how in blueprints those data types are represented by different colors. Well, this yellow one is a new data type we haven't looked at, and that is the vector type. Now a vector, as I've just very briefly mentioned, in this scenario anyway, corresponds to where in the world our objects are. It's location information, right? It's not necessarily to do with location. It involves, you can use them for vectors for rotation, direction, scale, etc. But the gist of a vector is it contains three numbers, right? One for the X, one for the Y, and one for the Z axis. So because the start node and the end node require three numbers, one for X, Y, and Z, it needs data in the form of vectors. So this first node we added here, get owning actor, just basically says, hey, we're interested in this object. This second one says, great, now that we have that object, tell us what the location is in the world. Then what we're doing is feeding that information into this start node. So now our line trace knows where to start. Next it needs to know where to end, and that's where this end one comes in. And to work that out, we're going to use this same node. Now the end location, like I said, we want to send it down, so it's kind of roughly below us, right? So what we want to do is basically say, hey, to find the end location, start with the start location and just minus a certain amount from it, right, on the z-axis. Because if we look, in fact, might even be able to see it in the very bottom left corner of this. I can't really zoom in, that's a shame. But the bottom left corner here of this sort of preview window of our character, there's a little 3D graph, so you can see the z-axis goes up and down, which, by the way, if you know why that is, tell me why. I thought it'd be the y-axis. I thought that was just law, that the y one goes up and down, but hey-ho, it's the z-axis. Then in another direction, another horizontal direction, you've got x, and for some reason in another horizontal direction, perpendicular to the x, you've got the y-axis, right? So obviously if we want to send the line down, we're interested in the z-axis. What we want to do is tell our node to take the start location minus a certain amount of that location in the z-axis, and that will be the end location, okay? Hopefully that makes sense. So to do that, let's take this node here, which has the start location in it. Let's drag a second line off of it, place a new node, and let's just type a minus, because the node we want to look for is called vector minus vector. We want to take the vector we've got, the actor or the character's location, and minus a new vector from it. Cool, and then what we want to do, let me just reposition and zoom out a bit, is drag the result of that sum out into the end pin here on the line trace by channel node, okay? So how much do we want to minus? Minusing 150 in the z-axis works quite well, so give that a go. If, by the way, when you've done all this, if you're struggling to get this to work, this is a good place to come. Experiment with this, make the number bigger, make the number smaller, and see if that gives you any better results. Now, to help you test your line cast your line trace to make sure it's working, you can use this here. This is quite helpful. Draw debug type. This, well, what it will do is in your Unreal Editor window, whilst you're testing your game, is draw a line to represent the line trace so you can actually see it working and actually see how far down it's gone. Again, allowing you to adjust this number here, okay? And there's a few different options. You've got the for one frame option, the for duration, or the persistent option. I'm just going to click for duration. Then let's quickly save the blueprint, let's hit compile, and let's actually test to see if that worked, this line trace. So let's go back, and let's hit play. Okay, so if I walk around a bit now, there you go. So they're thin, but there you go, those red lines, that's our line trace. So you can see how it starts roughly where the character's hips are. Let me try and get a good view. There you go. So it starts roughly where the character's hips are, and then goes straight down towards the ground. You can also see there's a little square at the bottom. That's it sort of hitting an object and recognizing it, okay? So now we know our line trace is up and running and good to go. Okay, so now let's look at the other side of this line trace. What we want to happen when it does hit something. Well, what we want to do is find out, like I said, the physics material attached to that object. So, using the out hit little pin area, let's draw a line, and we want to use this node here, break hit result. Now if we open up the drop down menu, this is basically all the information that we could find out about the object that the line trace has found. The only thing we're interested in is, like I said, physics. So what we're going to do is use this pin here, this pinhole that's called physics material. Let's right click and type print string. Then what we'll do is we will drag the physics material pin into the in string, basically what we want to print using the print string node, and there we go, it's added a sort of transformation node. So we looked at these last time. Basically this node here called get display name, it's basically taking this reference to that object, that physics material, and returning it basically as string data. Now at the moment the print string node isn't activating. Whilst we're telling it what we want it to print, we need to execute it using these white pins here. Now we could just use the execute pin coming off of the line trace and drag it straight into print string. However, what's good practice is to use what's called a branch branch node first. So what I'm going to do is type branch in and use that. Now, what is a branch node? Well, again, if you've ever looked at any of my Unity series, you'll know that we use if statements quite a lot. And an if statement is basically a way of doing something only if a condition is met, okay? So, for example, you might create an if statement that says, hey, I want you to play a jump sound if the player presses the space key, right? It's nice and simple. And the equivalent in Blueprints is this branch. So if the line trace actually does hit something, then only then do we want to do something off of that. There's no point, you know, using this print string and later down the line playing sounds if the say the walk animation triggered a footstep, however the line trace didn't find anything. Okay, we don't want that to happen because there's a good chance we're not stepping on anything. You know, it might be an error for some kind. So that's what this branch is going to do basically. It's only going to trigger this print string and thus our audio later on if the line trace actually did hit something, if it's true. So what we're going to do is using the true execute pin here is drag into our print string node like that. Okay, so this is what we have so far. Okay, let's save our blueprint, let's hit compile, and let's give this another test. So now if we walk around, like I said, we should see the physics material. There we go, in the top left corner. So we're walking on tiles, so it's telling us it's detecting the tile. Now if I jump on this wood here, oh, I'll try and walk on it. There we go. It's giving us wood. Now let's also test the grass works. So what I'm going to do is click escape. Let's come over here. And what I'm going to do is basically just going to push this wall back so we can actually access the grass. Because at the moment we can't get outside. So I'm going to click on this back wall here. And then holding shift, I'm also going to click on these two cubes. So now all of that area is selected. Then I'm just going to drag them outside using this arrow here. There we go. So now we can access outside. Right, let's hit play and test that one more time. Okay, so let's walk over here. Now notice here, notice that's a default physics material as I walked up the stairs. The reason why is because I haven't yet assigned physics material to that. So that's a bit of an issue. But don't forget in Wwise, let me quickly escape actually. In Wwise, if I click on footsteps and go back to this other layout, remember we have a default switch assigned, which is tile, i.e. if a physics material isn't found, this is what's going to play, okay? Which is quite handy in this scenario. So if I was, I'm not going to, but if I was to leave this alone and not add a physics material to it, the default sound we'd hear is tile, which actually works quite well because these look like tiles, okay? So that's just a little bit of background into, say, if you miss an object, what's going to happen and how Wwise and Unreal are going to work together to resolve the issue. But anyway, got distracted there. Back to testing. So let's walk down the stairs. So tile, material, tile again. If I walk on the grass now, there we go. Material grass. It says it in the top left corner. Last thing I want to test. Obviously, earlier I was talking about how we can override specific objects and assign physics materials despite their texture and despite their meshes. Well, if I walk on this top one here that I assigned the wood material to, there we go, material wood. Despite the fact this is the exact same mesh as those tiles indoors, it's still giving us wood. Okay, cool. Okay, so the next thing we're going to do is set up a new node. This node is basically going to set the switch in Wwise. It's going to read that physics material and say, hey, before you play our event, we want to take this switch group and set the switch as thus. Okay, so the way we do that is off the last node we use, which is print string. Let's drag an executable line and let's type set switch. Okay, so this is the set switch node. It's nice and simple. The way it works is using these two sections at the bottom here, you basically decide which switch group you want to control. So in our case, it is our material group. And then you say which switch you want to assign that group to, or the value of it to. Now, as always, it's very important you get the names correct. So material, I'm just going to double check if I go back into Wwise that my switch group is called material and spelled exactly the same. So it looks right to me, material. And if I go back into Unreal material, cool. So now that we're saying, hey, we want to control this switch group, what switch do we want to assign to it? Well, the way we're going to do that is basically, we're going to delete all of this first. You can use the break hit result node to assign a switch value to this set switch node, but we're not going to do that in this scenario. I'm just going to delete these. What we're going to do is right click and we're going to say get surface type, and we're going to use this node here. So if you remember earlier when we created these three surface types, tile, grass and wood, well, what this node is going to do is it's basically going to use the line trace. The line trace has obviously found an actor object with a physics material attached to it. Well, it's going to read that physics material and the surface type we assigned to it, and it's going to return that surface type out of this pin here. So let's drag this line and let's stick it into switch state, and that's also going to convert it into data form that this node can use, which turns out is called name. I've not heard of this data type before, or this return value, whatever it's called. Must be specific to Unreal. But hey, there you go. That's the data type it needs. So that's what it gets converted into. And what we can also do, if I drag another line off a return value, we can also display it as a string as well, in case we want to keep testing, the surface types we found. So now what the string will print, instead of the name of the physics material, it should print the surface type assigned to that material, which we'll test out in a bit. Okay, cool. So we've set our switch group and we've given it a switch that we want to assign to it. What next? Well, next is time to do it again, basically. Remember, now we want to decide whether or not the player is walking or running. So let's once again drag the execute line out of here. We're going to type switch state, or set switch, sorry, again. There we go. And this time, the switch group we're interested in was called, and I might have to double check this, walking/running. Again, go back into Wwise, double check. Oh, there was no / right. In that case, I'm going to click rename. I'm going to copy that, go back into Unreal, and I'm just going to paste it into there. So I know it's exactly the same. There you go. I nearly made a mistake then. Okay, so we've got this set switch node. How are we now going to assign a switch to the walking running switch group? Well, what we're going to do now is we're going to go way back to the beginning of this little blueprint chain we started. Now, obviously, all of this is stemming from the play run step notify. Now, if you remember back to the first episode, we looked at notifies. Whenever the player is using this animation, the running animation, the play run step notified is triggered. However, if the player is walking, the play walk step notify is going to trigger. So we've got two notifiers, right? And at the moment, we're only using one. So what we need to do is find a way of using those notifiers to tell this set switch node here which switch is going to be assigned to. Now, really, we want both of those notifiers to trigger this whole chain. Like I said, we just want to decide, we just want to be able to tell which one out of the two we're using. So let's first make some room up here. And then what we're going to do is I'm going to pinch the play walk step notifier that we created last time, break the pin off of there, and I'm going to drag it up next to our other one. There we go. So we've got play walk step and play run step side by side. Okay, so to detect which one of these notifiers fired this chain or started it, told our audio to play, what I'm going to do is I'm going to create a new variable. Now, we looked at this last time, we created our speed variable. This time I'm going to create a Boolean variable. Now, I can't remember if we talked about Booleans yet, but basically a Boolean variable, or the Boolean data type, can only ever be true or false, okay? Now, we've only got two conditions here, the play run step and the play walk step notifier. There's only two things that can fire this chain, so that works quite nicely. We can say if the play run step notify starts this off, then we're going to set this variable to true, and if play walk step fires it off, we'll set it to false, and then we can use that to set our switch. Okay, so I'm going to call this Boolean variable walking running. Then what I'm going to do is I'm going to drag it onto our event graph. There we go, and we want to set the walking running Boolean. There we go. So what I'm going to do is take play run step. So now when it first fires and the animation first takes a step, is we're going to basically trigger this node here, which will then trigger the line trace, okay? Now, if it's the play run step that triggers all of this, we're going to set walking running to true. However, let's go drag this off one more time and set it again. If the play walk step triggers it, i.e. if we're walking instead of running, then we're going to set walking running to false. And again, after that, the line trace will be triggered. So now why have we added this? Well, now that we've set this variable, we can read it at the very end of this big line of blueprints we've made and use it to set this switch here. Now the way I'm going to do this actually is I'm going to drag this up here. I'm going to actually quickly, I'm going to break this pin and I'm going to add another branch node that we looked at earlier. There we go. Okay, so now the branch node is going to do two things. If the branch node is true, it's going to use this set switch node and assign the walking running switch group to the running switch. However, if it's false, it's going to do the exact same thing. So let's get another set switch node. And let's also just copy and paste the name of the switch group we're using. However, this time it's going to set it to walking. Again, double check that these are correct. So if we go back to Wwise, are they called running and walking? Yes, they are, with capital letters. Brilliant. That's all good to go. Now, what is going to determine the condition of this branch? What's going to determine whether or not it's true or false? Well, that Boolean we created. So let's drag off a line from the condition pin. Let's search it up. So let's go walking. There we go. So we can now use the walking running Boolean variable. Notice how it says get, so we're getting the value of it now. We're not setting it. We're not saying whether or not it's true or false. We want to find out whether or not it was true or false, because earlier we set it up here, okay? So if we go back here, now whoops, didn't want to do that. Now the walking running Boolean variable will determine whether or not this branch goes up to here, set switch to running, or set switch to walking, okay? Fantastic, right, nearly there. So now, earlier we talked about how in the last episode we changed the parameter, do you remember, on our running random container? Well, we still want to do that. So if the branch determines it's true and we set our group to running, we want to set the parameter. So let's find where we, created that set RTPC value node last time. Remember, the way it worked is we found the player speed parameter, and using the speed variable, we assigned a value to it. What I'm going to do is I'm going to highlight all of this. I'm going to hit Control X to remove it. Then I'm going to come back up to where we've been editing today, zoom out a bit, then Control V. Again, this will be Command C and Command V on the Mac. I'm sure you know that if you have a Mac. Then let's drag it into position. And yeah, I'm only going to trigger this if we're running. So I'm going to make sure that the set switch node is the one that's going to activate the set RTPC value node. There we go. Finally, the last thing we want to do is play the event, right? So let's right click, let's type post event, enter, there we go. So what we want to do is basically we want to use both this chain here, or this branch here, and this branch here to trigger it. So let's take the execute node up here, assign it to post event. Let's do the same here. There we go. Then let's decide what event we want to play. So let's click select asset, and we'll click our footsteps event we created earlier. Okay, so the last thing to do is to give the post event node a reference to our actor, the object, again, where we're going to play the sounds from. So let's drag a pin off of the actor, or drag a line off of it. Let's type get owning actor, and we're going to use that, the get owning actor node, in order to reference our little character here. Now, in order for pretty much all of this to work, I think except bar set RTPC value, we also need to do the same. We need to use the actor pins on them to reference an actor. So what I'm going to do is just drag lines off of the set switch nodes in order to reference the exact same actor. There we go. I suppose we could make, I'm just trying to organize this a bit better. Let's put that there, and that maybe there-ish. God, these lines get messy, don't they? But there we go. So now you can see it's sort of referencing, using this one node, we're referencing the character here for the switch and the post-event nodes. Now, we've written quite a lot, and whilst that is basically everything, there's one or two more things I want to do. The first thing I want to do is just delete all of this because we're not using these anymore, so get rid of those. The final thing I want to do is add one of these white boxes. So these are called comments, and they're really good for organizing your blueprints, okay? For now, whilst we could add a comment for each individual section, and that definitely would help organize things, I'm just going to add one for all of it. So I'm going to right click, I'm going to type in comment, add comment, and then let's see if I can grow this just to encompass everything. Okay, there we go. Let's just position that. We can drag it down with the rest of it. Then if I zoom into the top left corner here, I can give it a name. So we'll call this playing footstep sounds. And again, this is simply just an organization tool. So you can look at your blueprints and see, right, this section does this section does that, and so on. Okay, so I tested this, and turns out I made a couple of mistakes. So let's quickly fix those. Mistake number one, earlier I said that all of the set switch nodes, as well as the post event node, need a reference to the actor object that they're, sort of being played around, or, been playing for. Well, I forgot to assign that actor to this set switch node, the one that actually controls our materials. So let's quickly do that now. Let's drag a line off of actor, and again let's type get owning actor and select this first one that pops up. And perfect, there we go, that's now sorted. The second one, turns out this sort of little chain thing we've got going on here that goes from the line trace node all the way to the set switch actor doesn't work. And the reason why is because at the moment we're converting the hit information, or the hit data, into that surface type data that we looked at earlier in the settings, then into this name data. That doesn't quite work. What we need to first do before we turn the surface data into the name data, for some reason, I don't know why, is first turn it into string data. Now, thankfully, we're already doing that here by trying to display the surface type that we found using the print string. So what we're going to do is drag a line off of this node here into the switch state pin on our set switch node. There we go. And it's getting really messy now. And that's created a new sort of conversion node. Now what we're going to do is drag that down here. Let's delete this old one because we're not using that anymore. Click delete. And let's just do a bit of organization so we can see everything. Okay, there we go. Hopefully that's a bit clearer now. So now we're converting the surface type into string data first. Then we're using this node here to convert it into this new name data, which I've never heard of. And that seems to get it to work. Okay, so just bear in mind you need to do that as well. Okay, now let's save our blueprint and let's hit compile. And one more time, let's give our game a test. Fingers crossed this time. Right, run around. We hear tiles. If I jump on these crates, we hear wood. Brilliant. There we go. That's working. So if I now go outside, let's test grass as well. There we go. Brilliant. I also want to test that wooden surface up there. Make sure that plays wood as well. Because remember, I manually overrid the physics material for that one. Perfect, it plays wood. Okay, I think one last change I'm just going to make is to this print string node. Now that I know things are working, I don't really need it. So I'm just going to disable it. I'm going to quickly click on the drop-down menu, and I'm going to untick this box that says print to screen, and also untick this one that says print to log. And now I'm hoping this shouldn't print any more text in the top left corner, just to keep things nice and clean if I ever want to do some more debugging using another print string node later on down the line, okay? In fact, I think what I'll do is I'll do the same for the line trace by channel node. I'm going to change the duration of the debug type to none, and now I won't see any more lines, okay? Because I know things are working now. But yeah, long story short, that is pretty much everything. We're all done on the blueprint side. We've got everything working. The only real thing, I'm going to say this one more time, the only thing really left to do now is go back into Unreal. Let's quickly minimize that and just cover this entire game with physics materials of some type. Again, whether that's on the textures, on the meshes, or just overriding the object's collision in general. So off screen, that's probably what I'm going to do. Go around this whole level and just add those physics materials we created here to stuff, and also find a folder for them because, like I said, it's not very organized at the moment. But yeah, that's everything. We're done now. Oh, one thing I'm also going to do is also move that back. But yeah, that is now everything. So yeah, thanks again for watching. Let me know your thoughts, your comments, what you'd like to see from this series or the channel in general. Like I said at the beginning, if you'd like news, updates, stuff from me via email, and you'd like some free lessons in some of my courses, then check out the link in the description where you can sign up. That'd be really appreciated. Other than that, like and subscribe, I guess. And yeah, I've been Henry Scott. Thank you very much for watching, and I'll see you in the next one.